I'm Antonio. I'm a data architect at Agile Lab. And the purpose of Agile Lab, and for my professional purpose for the time being, is to elevate the data engineering game. And this guy over there instead is Osvaldo, is my dog. He's not into data engineering yet, but is overhearing a lot of meetings. So maybe in a while he'll join our company at Agile Lab. So let's say you have built your internal data platform and you are at the top of your game of data engineering. So you've probably built transactional data pipelines, single table transactional data pipelines, using the um, processing engine of your choice, and sitting on top of an open table format that can be Iceberg. And today is going to be a lot about Iceberg, but it can be also Delta Lake or UDI for the sake of this presentation. On top of that, you can have any engine that supports the table format you chose. On top of that, you have built data quality checks. Again, the tool of your choice that integrates well with your engine or Iceberg or both. And common choices are Great Expectation and Monte Carlo, but you can build also your own SQL query or your Spark jobs, whatever works for you, that is able to check that the quality of your data is how you want it to be. For sure, in order to run those data pipelines, you'll need some orchestration tool. That can be Airflow, Prefect, Dagster, whatever works. The important thing is you are able to create DAGs, orchestrate different jobs. And the cherry on top is to have data lineage. So to be able to programmatically know how data is being produced inside your data platform. And this can be achieved using almost any data catalog, like Data Hub, Apache Atlas, or there are other products. Or you can still use a tool, but base that on an open standard like OpenLineage. So you have all these tools, and one of your pipelines looks like this. So you have some IoT devices that are sending data to an object storage, and from there you have your first ingestion job. Let's say it's a Spark job that loads this data into a Iceberg table, and from the table, other jobs are consuming it and producing higher value data. So we've talked about data quality, and data quality usually is implemented like this. So the same table as before, you periodically run some of these data quality jobs that are able to to give you a green or a red light in terms of quality of your data. And so let's say it's a day like any other, so everything's fine, data quality is at point, pipelines are running smoothly, and at some point you have some unexpected behavior on your devices maybe, and these devices start sending data that has never seen before. So this weird data uncovers a bug on your ingestion pipeline, and this bug leads to some bad data in your first table. And in a glimpse, you get bad data all over your pipeline. And this can be actually understood by your data quality jobs on dependent tables, or it can be even more subtle and have some data quality checks not even catch the problem. Okay, so it's even worse, because if you don't have lineage, you don't even know that you are affected, because your checks on the last table are not, let's say, comprehensive enough. So at this point, you are a catastrophe happened to you, and you have have to choose either to take decision based on bad data that you know it's not at the quality you want it to be, or take decision without using any data, like with gut feeling. And after that, you realize that, and then you have to fix the problem. So how the remediation looks like. You have to track downstream processes, and you can use Lineage for that. You have to stop them. You have to fix the code, fix the data pipeline so that you don't let any bad record inside your data lake or your lakehouse. And at the end, apart from fixing the pipeline, you also have to revert data to a good state. Okay, so just before bad data entered there, replay the input. So it's quite cumbersome. It's a complex process. It looks like 4 steps. Usually takes days or weeks to have this in place for any single bug that corrupts in some way your data. And so we may ask ourselves the question, but so how do we avoid shipping bugs in production? Because bad data looks a lot like bad software, leads to bad outcomes in the end. And well, it's easier, right? As we don't deploy code that does not pass tests, we shouldn't deploy data that doesn't pass tests. And tests for us are, data quality checks. And this is such an easy concept that it's also a known pattern that's called write-audit-publish pattern. The problem is you have many challenges applying this pattern on a lakehouse architecture. One way of achieving write-audit-publish is that you write to some, let's say, folder, to some temporary table, staging table. Then you audit that table, and finally you rename the table or rename the folder so that it matches the one that your consumers usually read from. But this is not easy at all because you have no atomic rename on object storages, which are the foundation of your lakehouse. Second thing that you probably are not able to do, instead of writing data, moving it, and then moving it after auditing, you could write, audit, and then copy. But, well, data is usually big in these cases, and so you cannot afford to do it twice. Might be because it takes too much time or because it costs too much money. And also, it's not that you cannot perform write, audit, publish on the fly unless you limit yourself to one single processing engine. This means that both the processing logic and the data quality checks should be implemented on the same process. So how do we solve this on the lakehouse architecture? Well, the hero of the date is a monster, and it's a Loch Ness monster. Here I present to you Nessie. And Nessie is a technology, okay, that brings Git-like features into your data lake. And you can think about Nessie as a metastore on steroids. So it holds metadata about your tables the same way good old Hive metastore does, but also implements some Git features on top of it. So you have versioning, branching, merging, and tagging. And so here I propose some way of dealing with this write-audit-publish pattern using Nessie. And you will see it's really, really simple. And I also have a demo about this. So let's say our workflow looks like this. First of all, we create a new branch. Let's call it staging branch. Then we write the new data on this staging branch. Finally, we validate this data using our data quality checks. And then if everything went well and the data quality checks are passed, you can merge the branch and finally delete it. Otherwise, if something goes bad in your data quality checks, you can send an alert to someone that will check out what's happening. So let's go ahead with the demo. Let's say we have a table, a very simple table, 4 columns. You have an ID, a name, a surname, and a tax ID. And if we go to Nessie, we already created this table. As you can see, we can see the customer table, and we can also look at this commit history, and we can see there is only one commit. It's when I created the table before starting the presentation. And so right now, as I said, we go ahead and create our branch, and we do that through Nessie CLI. We could do that from a Java client if we want to, and it's only a metadata operation. So as you can see, it's very, very fast, already done. And we go back here, we refresh, and we can see we have our staging branch, which is exactly the same as the main branch. So next step, we are in this situation. We created the branch, no commits yet. The 2 branches, main and staging branch, are the same. Next step, we update our data. So this is a very simple job. We will just upsert some record based on the ID. And this is a Spark job because I'm lazy and it's fast for me to write Spark jobs, but can be anything that works with Nessie. So we can see before the update, we had 0 rows. Now we have 3 rows of 3 customers. So next step is to run the expectation. So let's look a moment into Nessie. Main branch is still untouched, 1 commit. Staging branch has 2 commits, and this second commit added those 3 rows. So next step, apply data quality checks. I used Great Expectation, and I can run Great Expectation through Spark. And Great Expectation is cool because data quality checks are declarative. So I can just write this JSON-like notation, and the engine, so Great Expectation, will pick these rules and apply using the engine, the processing engine I chose, so Spark in my case. And I just say, I want to have these 4 columns. I want ID to never be null, and I want tax ID column to be unique. So let's go ahead. This is the Spark job, the PySpark job that implements that. It's really simple. I just load those JSON files, load my table at some given reference. So at this reference is the branch. And I just run them. I call validate and I get some result. And if everything goes well, I print success. Otherwise, I exit with something different from 0. So let's run data quality. And we hope everything went well. And so we have a print success. Okay, so data quality was fine. Next step, let's merge. And so let's merge our branch into the main branch. This is, like, as you can see, very, very fast. And so if we go back to Nessie, we can see that the staging branch has 2 commits, and now also the main branch has 2 commits. And so we are in this situation. We merged. Now, finally, we can just delete our branch. So far, so good. So another day, another run of the pipeline. So let's go ahead, create a new branch, and let's update our data set with some wrong data. Okay, I'm doing it on purpose, obviously. And so as we can see in a while, we will see that we have now 4 rows. We have another customer, Albertino Anstanino, which has exactly the same tax ID as Albert Einstein. Okay, so that, if you remember, our data quality checks is a problem. And so if we run our data quality checks on our staging branch, we will get a failure, hopefully. And here it is. So success, false, failure. It was exited with 1, and we can also look here and say that the problem was that there were two albi, okay, two tax ID that are the same. And so that's it. We should send an email to someone that will check this branch, is able to. So I've never tried this, but no, I won't try. But someone can check out that branch, see how's the data, what happened, why there are two customers with the same tax ID, and think about what to do next. But we never merged the branch, so this data was never exposed to our consumers. So what are the takeaways? Using Nessie and Iceberg, we can decouple processing and audit. We are able to never expose bad quality data, and also we are able to revert changes if they ever happen. And this supports all kind of write modes that also Iceberg supports. So it's both update, append, overwrite, and delete. This looks like nothing today, but if you're in big data since the last decade, you will know that these things that we give for granted were not granted like 3 years ago. And you can say, sure, but last year at this very conference, I've seen a talk about Sam that says that you can achieve the same simply using Iceberg. And yeah, you're right. Without Nessie, you can do kind of the same. You can achieve the same result, but it's kind of more complex. And also, we just scratched the surface of what Nessie can do. So this was a very simple example, but with Nessie, we can implement a lot of other workflows to match our needs. And one of them is feature testing with diverging branches. And we will go deeper on that later. You can also update atomically and consistently multiple tables, something that with Iceberg alone you are not able to do. You have transactionality on a single table. And so you can do that on multi-step complex data pipelines because you have this very powerful concept of branches that you can use to actually do whatever you want. And when you're good, when you are safe, you can merge it back to the main branch and leave it to your consumers. And so feature testing. Let's say you have a new version of a data pipeline. This new version shouldn't provide any functional change, just performance improvement. And you want to be really, really sure that it behaves exactly the same as the prior one. And we know that you can test this in dev environment, QA environment, but data is really unique to the real data. Like you can find pattern in the production data that are not there on QA and dev. So how do you do it? Well, with Nessie, it's quite simple because you just create a new branch from the main branch. You keep running the old pipeline on the main branch, and you run the new pipeline on the just created branch. And you run for 1 day, for 2 days, for a month, whatever you want. And when you're ready, you just check that the two branches are exactly the same. And if they are, you're good. You can merge to the main branch or just switch scheduling, but you are 100% sure that the two pipelines behave exactly the same. And well, we've scratched only the surface of the iceberg that Nessie is, but let me talk a bit about the downsides. So Nessie is quite a new technology, and I was very delighted to use it so far, but I have to point out some things that can be better and surely will be. So first of all, authorization is still really primitive. So it's a lot static. You have to restart the Nessie server when you want to change authorization rules. So it's a bit inconvenient. Also, and this is like the most functional, biggest functional problem, is that you have one data lake, so one Git history, one Nessie history for one Nessie instance. This means it's like working with a monorepo. You have all your tables that are using Nessie on the same history. And if you have tables that are not linked to each other, this is a bit inconvenient because reverts are complex. Okay. And right now it supports only Iceberg and Delta Lake, so no plain Parquet tables, no CSV files, no Hoodie. Okay, so you can use Nessie only for these new tables that you are working with on these table formats. And since it's not a general purpose metastore, you will still need to run your Hive metastore or Glue metastore or whatever metastore of your choice on the side of Nessie for all the tables that Nessie doesn't support. So it adds to your team a new piece of infrastructure to take care of, to deal with, and it's quite stable. I've never had a problem in production with Nessie so far. I cross fingers right now, but still, it's another piece of infrastructure. And that was it. I thank you guys for attending this talk, and I'm open to any question. You can find me on LinkedIn, on Twitter, and I will publish all the demo and slides on GitHub.